Hi there, maths enthusiasts. Welcome to today's tutorial. Of course, you are highly welcome to Prince D TV. Today we are going to tackle one of maths' most interesting topic, and that is function. I will be introducing you to functions for you to have a better understanding, because recently we've had some slight misunderstanding where some students and even some teachers, sometimes they are a little confused with functions. So I don't want to mix it with mapping. Gradually we'll take each step at a time, but today, just like I said, function will be our main concern. So we will be looking at the aspects, the components that makes up a function. What is a function? The domain of a function, the codomain of a function, and of course, how can you differentiate a function maybe from a mapping or a relation itself. Those are very, very vital aspects when it comes to function. So as usual, without wasting much of your time, let's dive in straight away. So normally a function is a relation that is so specific where each input is related or mapped to one and only one output. For example, I made mention of a relation. I would like us to look about what a relation means in this case of functions. A relation is simply a connection between two or more sets. So a function is a specific type of a relation, okay, between two or more sets. But it is this kind of a function, this kind of a relation rather, that is mapped or related, associated with one and only one output. So we have two sets. A function, a member leaving maybe set A or group A, is related or associated with one and only one member to the other set. That's a function. In a beautiful example, maybe in daily lives, I'm using the case of a phone book. We all have phones, right? So in this case where you might have your phone book, each contact or each name rather in your phone book has a specific contact. So for example, if you have my contact, if you have my name, and under my name you have just one specific contact under my name, that is just a specific name being given or related to a specific contact number. I'm not talking about two contact numbers, no, a single contact number. So that is a function. All right, now another good example again in daily life is an email. So if I'm having an email, just my name is assigned to that specific email address. So a name given to a specific email address, it's a very beautiful example of a function. All right, thank you so much. We are going to jump right away into what is known as the domain of a function. So these are the elements that makes up a function. So when we talk of a domain, the domain of a function simply means those elements that are inputs which are defined under that function. Those elements which are inputs that are defined under that function. Then we equally have what is known as a codomain. So for a codomain are now those elements, we call them the outputs, that is the final result of that function. Those are what makes that function have a meaning. Okay, so like in mathematics, we always relate functions in such a way that, for example, if you have an equation, for example 2x, that's a function, right? It means that the output there are the result when you take the first set, the input, and you substitute into that function, which is 2x, and it gives you a result Now that will be the output. So the output are exactly what makes that function have a meaning. Now, all the elements that have members in the second set, which are the input. So if you realize that you have two sets, maybe for example in this case I will decide to use A and B, set A, set B. Then from set A they are mapped or related to elements of set B. Now all those elements under that set B, which we know as the codomain, if they are related to elements in the first set, which is set A, then all of them that are related to the first set, they are known as the range. So under the codomain, the elements under the codomain that have members in the first set are known as the range. Okay, good. So lastly, before we go into some practical examples in mathematics, how can you differentiate a function? How can you look at a particular relation? Remember we said earlier, a function is this specific type of a relation, that is having exactly just one output related to one member in the other set. So how can you look? Because one thing you should know, all functions are relations. Absolutely all functions are relations, but not all relations are functions. You need to know that not all relations are functions. So how can you know? The bone of contention is how can you look at a relation, an equation or whatsoever, and you can be able to determine and tell this is a function, this is not a function. So the key points are, first, it is a specific one-to-one relation. One-to-one relation. That is the main idea you should grab in this tutorial. When we talk of a function, the first thing that should come in your mind, that should pop up, is that a function is a one-to-one relation. Alright? So with all of this, I believe you've gathered the basic knowledge, an idea that will suit you better, and with that, let's jump and look into some beautiful examples practically and how we can be able to tell. So remember, our main concern is to leave this tutorial and be able to tell, to differentiate that this relation is just a relation, it is not a function, or this relation, it is a function. Alright? And today, by the end of this tutorial, you'll be leaving with flying colors. Alright. TV fam, just like we said earlier, now we are looking at some practical examples mathematically here. So we have two relations on our board, two relations, and we decided to separate them. I call this relation 1, decided to put it for short R1, and here relation 2, I decided to put it R2. Mathematics has its beauty. So something can be, we can put it for short for easy understanding. So the R, please pardon me, is known as a relation. So I've decided to label this relation 1, relation 2. Now let's begin with relation 1. How can we identify and tell that this is a function or this is not a function? So with relation 1, like I told you earlier, this is set A, the first set or group, we can call it like that, and this is set B. So from our basic understanding, a function we made mention is a specific type of a relation where the inputs are mapped or related or matched or connected, anyone you like, to the outputs So each element in A is connected or must be connected to only one and exactly one element to the second set. So here, let's verify. We have A, B, C, and D. Alright? A is related or mapped or connected to just one element, which is E. Okay? That one verifies that it is following the rule of function. All of them have to be the same, right? Okay. B, one element, which is E. C, no element, no issues. I'll come to that. D, one element, H. Now, you need to note that, so all of them have just one images on the second set, and that's the rule of a function, right? But somebody might ask, but C does not have any image on the second set, or it's not mapped. Yes, it can be like that. This is the domain set. The set where of the set of the inputs, the beginning element is known as the domain, and the second set of the output element is known as the codomain. So the domain, all the elements must not be used, but you must understand that for any element that is being used, let it match to only one element in the output set or the codomain. And also the codomain, not all of the elements must be used. For example, F and G, they have not been used, but anything that is being related or mapped or connected to another, let it follow the law of function. So this is a function. That's why I wrote here function. This is the domain, the first set, and of course this is the codomain, the second set. It is a function, irrespective of the fact that C has not been used, F have not been used, G has not been used. No, the thing you should note, or the bone of contention, is that if any element is being used, let it follow that law. You should have just one partner, one member to the other set. All right, thank you so much. Now, can we please look at relation 2? Now, under relation 2, we follow the same. The first set or the input is not always the first set. Remember, they can interchange B and A. So the arrow matters. The arrow really matters. Those arrows, they matters. For example, if we decide to take B and send it this way, do you know that if we have maybe B and we have A like this, and our arrow simply points, it means that our elements, they start from B to A. So the arrow tells you or indicates the direction. It tells you the input elements. So I know that my input elements are A because the arrow is pointing towards B. Now look at something. If we had a function here, two sets, my arrow is pointing from B to A. It means that A here is no longer my input elements. No. So that's something very important. Now B will be my input elements, just to highlight that. So A is mapped to E or related to E, so just one. A has just one element. B is mapped to E, just one element. They are following the rule for function. C is mapped or related to F, just one element. D is mapped to H. G has not been used, no issues. So all of them that have been mapped or related to other elements in B or the second set or the codomain, they have exactly one and only one element, which seals the law of function. So this is a function. Domain, codomain. Are we there? Now, without wasting much time, we'll look at an example where we can also tell that this is not a function. Alright, Prince TV fam. So we're about to look at other good examples where, in this case, they are not functions. We're just coming from looking at examples that we can be able to identify and tell that these are functions. So again, we have two relations. Remember, all functions are relations, right? But not all relations are functions. And here we're about to seal that in less than no time. We have relation 3 and of course relation 4. So let's begin with relation 3. They both are not a function, but how can we know? How can we be able to identify that? All right, we know the rule. Remember, a function is a one-to-one, a specific one-to-one, exactly one-to-one. All right, I look at my arrow. This is set A, so I know these are my input values. A is having one element E. The same A is having another element F. Already, what does that tell me? It has failed the law of something to be considered as a function. Okay, it has failed that law. A should be connected to one and only one, either E or F, not both. So already that one tells me no need for me to check the rest. The rest are okay, but since A is part of the input element, it has spoiled everything for it to be a function. So that is why I wrote here not a function. I hope you grab it, and if you did not, then I can assure you that with relation 4, then you will be able to understand and seal this once and for all. So with relation 4, now my arrow is pointing the opposite direction. Already, what does that tell me? It shows that this is the first set. This is the input. These are the input elements and these are the output based on the direction of the arrows. All right, E is having A, the same E is having B. Wow, it has failed the law despite the fact that H is having D. Remember, Mr. Functions has his rule, and he has said for you to be able to call by my name that you are a function, it should be related to one and exactly one member element, whatever you can decide to call. E is having A and B. It has spoiled it up. Remember, all of the elements must not be used, but whatever is being linked to another should respect that law. So both relation 3 and relation 4 are not functions. That's it. I hope you now have a better understanding about what is known as a function. Thank you so much. Thank you for watching, and I'll see you in the next tutorial. As usual, I remain your boy, Prince D. Much love. God bless.